Do you know what is Earth's magnetic field and why it is important? The Earth's magnetic field is an invisible force that protects us from the solar wind. The solar wind is a stream of charged particles that are ejected from the sun. It can erode or ionize the atmosphere, which can have harmful consequences for life and the environment. The Earth's magnetic field is generated by a geodynamo in the liquid outer core of the Earth. It has a field strength of about 50 microtesla at the Earth's surface and a dipole tilt of about 11 degrees to the Earth's axis. The Earth's magnetic field has existed for at least 4 billion years, but it changes slowly and can even reverse. The Earth's magnetic field forms a barrier around the Earth, the magnetosphere, which deflects or reflects most of the solar wind. The magnetosphere has a complex shape and structure, which depends on many factors, such as the interplanetary magnetic field, the Moon or the Earth's rotation. The Earth's magnetic field also influences the ionosphere, a layer of the upper atmosphere, in which a part of the air molecules are ionized by solar radiation or cosmic radiation. The ionosphere is important for the propagation of radio waves and the formation of auroras, which are beautiful light phenomena in the sky. Magnetic storms are strong fluctuations of the Earth's magnetic field, caused by the solar wind, when the interplanetary magnetic field has an opposite polarity to the Earth's magnetic field. It can lead to a reconnection, where the magnetic field lines connect and disconnect. This leads to an increased energy exchange between the solar wind and the magnetosphere. Magnetic storms can have different effects, depending on their strength and duration. Some effects are positive, such as more intense auroras or increased solar energy production. Other effects are negative, such as disturbances of radio communication, GPS signal or power grid. Magnetic storms are therefore an exciting phenomenon that shows us how closely we are connected to space, but they can also pose challenges if we are not prepared for them. The magnetic field has an indirect influence on climate by modulating the amount and type of cosmic radiation that reaches Earth. Cosmic radiation is a high-energy radiation that comes from space. The theory is that a stronger magnetic field deflects more cosmic radiation, leading to less clouds and more solar radiation. A weaker magnetic field lets more cosmic radiation through, leading to more clouds and less solar radiation. This could lead to global cooling or warming, depending on the state of the magnetic field. There is some evidence that the magnetic field has influenced climate in the past. For example, there was a short reversal of the magnetic field about 40,000 years ago, which coincided with the cooling of Earth. Also, about 12,000 years ago, there was a weakening of the magnetic field, which coincided with a warming of Earth. The magnetic field is not constant, but changes slowly over time. It can change its strength, direction, or polarity. One of the most dramatic changes is a reversal of the magnetic field, where the north and south poles switch places. This has happened several times in the past, most recently about 780,000 years ago. Also, the magnetic North Pole has moved faster than usual in the last decades. This could be harbingers of an imminent reversal. These changes can have different causes, such as the movements of the liquid core of the Earth, the reconnections with the interplanetary magnetic field, or the influences of the Moon or other planets. The magnetic field and climate are therefore two complex systems that interact with each other. It is important to research them in order to better predict them. However, it is not possible to predict exactly when and how a reversal will occur, or what effects it will have. It depends on many factors, such as the speed, duration and complexity of the reversal. There are some signs that the magnetic field is currently changing. For example, the strength of the magnetic field has decreased by about 10% in the last 200 years. It can affect cloud formation and precipitation. which in turn affect temperature and greenhouse effect. However, this connection is not fully understood and depends on many other factors, such as solar activity, volcanic activity or greenhouse gas emission. It is therefore not easy to say whether the magnetic field can stop or enhance global warming.